Hi folks, this is the tree graph. Really what it is a static website hosted by GitHub that renders a labeled property graph as well as a list of links to all the nodes in the graph in a flexible way so a user can come here and zoom in and move nodes around and subset the graph and basically fit the use case that they need um, and keep me from spending a lot of time customizing how the graph renders visually. I've provided some preset filters that help. Um, and if I show all, you'll see there's about 200 nodes, 1,000 edges. Um, but this really does show how important it is to actually be able to subset a graph if you are presenting it visually. Next, I'll show you the free and simple tool chain I put together to create this. Okay, to arrive at our graph, we need data. I've used Excel to create that data. Essentially, you just need two tables, one of nodes, one of edges. And here, and I have an ID for a node, a type, and a bit of JSON with the properties. This is the edge table. Again, node ID, predicate. So jumping over to GitHub, you can see this is my repo. And in that repo, I've got two CSVs, nodes and edges. This is the same data from Excel. This is the clean version. And I've got a little Python script, picks up those two CSVs, joins them into a JSON file, which is a clean version, as well as this data.js, which is actually what's used. Same data in both files. Jumping back up to the top, here's that data.js and index.html. These two files are the only thing the website needs. In this HTML file, you've got two things, loading the JS, and you've got this cytoscape library. This is what's doing the rendering. Very powerful, not too difficult to use. Um, most of the HTML is just parameters for cytoscape, which you could tune, as well as some functions I've provided to power the buttons that subset my graph. Lastly, I've done this all in a branch called gh-pages, and when I do that, GitHub automatically will deploy that to a public link. And now you've got a graph available at a public link. So, thank you.